for a few minutes, and then we'll get our act together. Dominic Reisig.
Here. But again, like I said, I'm going to focus on cotton insect management. And if you don't grow cotton, it might be worth your time paying attention. You might pick up a thing or two, because the principles that we're going to talk about today for cotton insect pest management are, of course, going to apply to soybeans, which have a lot of similar problems to cotton, and potentially other crops as well, peanuts, for example. Of course, if you remember back in the non-BT days how bad tobacco budworm was, you'll recognize what's going on in this picture here. We have BT cotton on the left and non-BT cotton on the right. We're going to be talking a little bit today about some of the resistance that we have to some of those BT traits. But even with the resistance that we're having for bollworm, we're still getting a huge benefit provided to us by BT cotton from tobacco budworm. So I think that's kind of important to keep in mind as we sort of advance with the traits. We can't forget our history from where we've been, how bad of a pest tobacco budworm was to control, and how the system has changed as a result, and sort of the value that's given from BT traits. Hey, I did it. These data are aggregated from light traps across the state, and they illustrate very well what goes on with bollworm biology. So the blue line that you see there are the trap captures from a number of different years, 1993 to 2016, that you see there in the blue. And everywhere you see those little peaks, that's where we see flights occurring. So the way a light trap works is it's a trap that sits out there in the field, and I'll show you a picture of it in a minute. And it's got a black light, and the moths are attracted to that. They navigate by the moon and other sorts of lights at night. So they're attracted to that trap. They fly in it. They hit a vein. They move down to the bottom, and we have a little piece of insecticide down there that kills them. So we keep track of when these things are occurring. And of course, when you catch more insects, you know that there's more insects out there flying. And what these data show is that we have about 4 generations of this insect in our state every single year. And you can notice from some of those peaks where those insects tend to be a problem. So you notice this little peak early on, and this is where these insects emerge from overwintering. It had to be one of those buttons. All right, well, look at the peak on the far left. That's that generation that emerges from it's okay. Yeah, I was pressing that. We'll roll with it. That's the generation that emerges from overwintering. You notice it's very small. Actually, about 4 to 8% of the insects that go into overwintering make it to the next generation. We can get the coldest winter there is. We can have the wettest winter there is. It doesn't matter what Mother Nature throws at this insect. They'll be around. And they can make it up later in the season. You know, those bigger peaks right now, late July, early August, this is when bollworm tends to be a problem. This is when they're flying, laying eggs in our fields, surviving in cotton and soybeans. Notice the graph that's there in the red. That was the bollworm flight from last year. So although when we take an aggregate, we can kind of see the normal, every year is not normal. So you notice last year we had kind of a bollworm peak early. We saw them in July. They petered out in August when they're typically a problem. So when I get asked the question about what's bollworm going to do this year, I can tell you what they're going to do on average, but any given particular year, it's going to vary. We may have bollworm problems in August, we may not. And so right now we are in a bollworm flight. I checked some plots at Rocky Mount yesterday. We're actually having some places where we're having 10% survival on bolls. We're having 10% damaged bolls and 2 toxin cotton. However, checking our plots in Plymouth, we're not seeing much activity. Very important that you get out and scout those fields. Every situation is going to be different. All right, this is the light trap I told you about. And you can actually go to the light trap website that we have. We have what are called a portal system for cooperative extension. So if you go to our cotton portal, which is cotton.ces.ncsu.edu, you can click on some links that will take you to these light traps, and you can pull out individual data. Now, I pulled these out on Thursday or Friday last week, and you can see that they're rising in some places. And in the southern part of our state, that's in the blue there in the middle, Scotland County, for example, they're exiting a flight. So right now, we are in the midst of a flight. Very important to get out there and scout bollworms. When we think about bollworm management, we have to think about the system. We have to think about the other insects that are out there as well. And one of the insects that we really have to contend with in the Blacklands, more so lately, has been plant bugs. Plant bugs are difficult to control because they're very mobile, so the adults can move in and out of the field. They're difficult to sample as a result. Our thresholds have to change with blooming, and we have insecticide resistance. So when you layer all these things together just on one insect, and then you add the complexity of managing other insects on top of it, it becomes very confusing. So this is just a single example of let me skip to my plant bug site here. This is just a single example of spray trial results from plant bugs. These were our results from last year in Plymouth, and you notice that we had a number of chemicals that were effective up to 15 days after treatment. So there are a number of options that are out there. However, that being said, these chemicals are not consistent all the time. So we had some classes of chemistry that were effective last year. I want to point out some up there at the top. Those ones at the top were the effective chemicals. Those on the bottom were the less effective. Those chemicals there at the top, for example, fanfare, that's bifenthrin. Karate, those are both pyrethroids. Those were very effective in our trials last year. The year prior to that, they were no better than the untreated. We do have pyrethroid-resistant plant bug populations. We also have some organophosphate-resistant populations. In this particular trial, Transform performed well. I would say out of anywhere in the cotton belt, plant bugs are the most difficult to control with Transform in this location. So there's no chemical that's sort of a miracle cure. Each has its costs and benefits. So this time, during this time of the year, I think it's important to consider what a chemical brings to the table and what impact it may have on insects later in the season. So let's just use this plant bug as an example. If we had a field that had plant bugs at threshold and we were in a bollworm flight, we might want to adjust our chemical choice accordingly. We could choose the most effective combination up there, that's bifenthrin plus an orthine. It's very effective for plant bugs, but it also has some downsides. And one of those downsides is that it's going to wipe out all the natural enemies in the field. Some people don't like war analogies, but when we're doing pest management, it's a lot like war. What if you were to go in a war and wipe out the enemy that's there? Who's going to be left? There's a power vacuum. Somebody else is going to move in and fill that power vacuum. Sometimes you create a worse problem by eliminating the original problem that was there. It's the same way in pest management. Sometimes when we wipe out everything that's there, what moves in behind that is even more of a problem. And so when you spray with something like bifenthrin plus orthine, you can have a lot of bollworms behind that spray. You can flare up things like spider mites. So if we're in a bollworm flight, we might want to move to some chemicals that are a little bit softer on natural enemies. In this case, Transform would be a good choice, very soft on natural enemies. We also have to consider the efficacy of the product. I just told you Transform is sort of moderately effective. They're tough to kill here. If we have situations where we really need to clean up insects, we might go to some of the heavier hitting chemicals, but just realize we're creating that power vacuum there. There may be bollworms that we have to spray later on as a result of that insecticide choice. The same thing holds true for stink bug management, right? So stink bugs are very important to manage in the 3rd, 4th, and 5th week of bloom. Oftentimes this aligns with our bollworm flight. We have a lot of cotton right now that might be in the 3rd, 4th, and 5th week of bloom. It's attractive to bollworms, but we also need to control stink bugs. Same principle occurs for stink bugs that it does for plant bugs. For stink bugs, however, we have to use broad spectrum chemicals. So look at the most effective chemicals there on the top. Things like Bidrin XP, Bidrin, Brigade. These are pyrethroids, organophosphates. Then look at things that are less effective, things like neonicotinoids, some of the other pyrethroids. We have to go with some of our heavier hitting chemicals for stink bugs, but what we can do is we can make those, I guess, less heavier hitting in situations where we don't really need to clean up plant bugs. So if we have situations where we're running just at threshold, which would be 10% internal injured bolls on the 3rd, 4th, and 5th week of bloom, if we're running just at threshold, we might choose a chemical, say, just like Brigade, which is bifenthrin alone. It's effective, but it's going to be less impactful on natural enemies. If we have situations where we need to clean those stink bugs up, let's say we're running 25% injured bolls, which is 2.5 times the threshold, we might want to move to a chemical like Bidrin, just knowing that we're going to have to go and spray bollworms later on in the season. All right, this is the last slide, and this is the last thing I want to talk about. So we've talked about the impact on bollworm, but how do we actually manage bollworms themselves? We have a number of different protein stacks that are out there right now. We have protein stacks that either have 2 Bt toxins that are produced or 3 Bt toxins that are produced. So the 2 toxin proteins are things like Bolgard 2, Wide Strike, and Twin Link. These are going to be the older varieties. A lot of the newer ones that are going to be produced, especially those that are produced with the Enlist or the Extend Flex traits, they're going to be paired with something like Bolgard 3, Twin Link Plus, or Wide Strike 3. So these are the 3 toxin traits. It's very important that we manage these cottons differently. So for our 2 toxin traits, what we recommend is making sure that we scout eggs that bollworms lay. Why do we want to scout eggs? Because once larvae are established, they're very difficult to clean up. So this is an example of a trial last year that we had at Rocky Mount. We have the same trial this year. And this is where we sprayed a chemical called Previthon. When we sprayed based on eggs, which was in the 2nd week of bloom, that's where we had our highest yields and highest net returns. That's that tall bar that you see there with Bolgard 2 in the red. Notice what happened when we delayed our spray by a week or 2 weeks. We lost money on our cotton at some point. So it's very important that we make sure those sprays are there and they're there early. Also very important that we scout. Eggs are difficult to scout. But we must scout eggs, we must focus in the terminals, and we must focus on leaves near blooms. And the reason why it's important to scout is because what I just told you, we have populations at Rocky Mount where we have eggs. We have populations at Plymouth where we don't. Each field situation is going to be individual, needs to be scouted and treated accordingly. Probably the most common question I've gotten this year is, do I need to spray Previthon over top of Bolgard 3, Wide Strike 3, or Twin Link Plus? Our information indicates that you do not need to do that. So anytime we sprayed Previthon over top of Bolgard 3, Twin Link Plus, or Wide Strike 3, we lost money, we didn't increase yields. Are there going to be situations where we should have sprayed? Sure. Don't hold me to a number, but anywhere from 1% to 5% of those fields, we should do that. The odds are in your favor that you don't need to treat those with Previthon. These are not standalone products. They're not 100% effective for bollworm, but our highest net returns are going to be when we try and use those larval thresholds that are there and established. And I think this graph demonstrates that very nicely. And that's all I have.